Our message today is that Fraunhofer Institute for Integrated Circuits, which I'm working for, is ready to launch with the S-band. So I see the board is getting more and more empty here in the front, so also the companies are getting smaller now. So I'm representing a smaller company compared to what we have seen before. But in any case, I hope in this S-band success story we can be one part of the puzzle. I'd like to give some short introduction first on satellite-based broadcasting in Fraunhofer, talk about IP cores chipset development, which is currently our main focus in the S-band initiative, and give some insights on the performance of physical layer of DVB-SH. So this is the outline of today's presentation, which I have, think, already summarized. So, as Antonio introduced, we have a long history in satellite-based broadcasting systems, and for example, one is the XM, where Fraunhofer made system design and all generations of receiver chipsets, which are currently being deployed on the market. Also for this ESDR system design, which is a European standard for satellite digital radio, we made system design and the first generation chipset. But apart from satellite-based broadcasting, Fraunhofer is also offering wide ranges of reference solution, not only in satellite, but also in terrestrial, like DRM, DAB, and so on. So our Fraunhofer Insight quality is more known to the OEM community than to the end-user community, so we're not selling any terminal branded Fraunhofer. But as a let's say, supplier of chipset, our quality is known. Besides that, we're always aiming for improving satellite quality of service, satellite bandwidth efficiency, because we are a true believer in a satellite-based broadcasting system, where here in Europe now we have the first time the chance of participating in this success story. So besides from running projects which are on IP cores, which are on chipset development, we're doing the next step already forward. So we're trying to measure the benefit, for example, of spatial diversity. So next step, as has already been mentioned in some presentation before, adding additional satellite. What is the additional benefit of doing so? For that, we're developing channel measurement equipment and a lot of field trials, either in L-band or in S-band, with existing satellites, be it in Japan, in the JOTIJA project, or in Europe using existing L-band satellites. So as a summary, for system and receiver design in satellite-based broadcasting, we are not a too bad solution. We have a lot of partnership with industry, so it's I wouldn't split, because there is a seamless transition between research projects, commercial projects, but this is just an overview of a few names of the satellite community which are important in this sense. For commercial success of this S-band, we believe that partnership within the industry is the key to commercial success. So some words on market needs for IP cores, receiver chipsets. So we are currently, not only currently, but all the time since 10 years, committed to update our know-how, to update our IP portfolio. So we are currently developing mainly DVB-SH as an IP core, also with the help of ESA. We are one of the two partners in this receiver chipset program that ESA has made. If there are requests from customers, this chipset is directly transformed into chipsets. So as an example, this ESDR solution, which is a say satellite-focused chipset, is available through STMicro, and all the physical layer implementation has been done on our IP core. On the other hand, we are since a long time understanding that the integration of this chipset with other multimedia components is key. So we are not only focusing on, let's say, developing some sort of fancy channel decoder and so on, but also about integrating with other components, be it on the same chip or be it in the same terminal. So, for example, audio-video decoders, conditional access systems, but also things which are required for inclusion with positioning, messaging, emergency systems, also integrating return channels. And also one important part is that the integration of such terminal is already started and fully done before even the chipset is in the market, because we do this based on prototypes and emulator platforms. So how do we react to market needs, but at the same time try to act as a market driver? So for small quantities, don't take the number as fixed. This is just a rule of thumb here. For small numbers, we are typically doing our implementation on FPGA-based platforms. Also can be done for a first system rollout with a few hundred receivers. Antonio called it once the friends and family program. For quantities around 20,000, still some relatively cost-efficient solution would be semi-custom ASICs. And as soon as we go into higher quantities, then clearly there is the need for full custom ASICs, including also other components, as I said, like tuner front ends, like audio-video decoder, and so on. And the choice of implementation basically is driven by the commercial commitments of the partners in such a program, and according to, let's say, the market requirements for such chipsets. So as we are also investing a lot, I mean not the same numbers as a Eutelsat or an SES or an ESA is investing, but also we pay our share in the development. On the one hand, we benefit from ESA funding. On the other hand, we invest also a lot of money in this program. We also do regular review of the satellite-based approaches, which are lifting off here in Europe. And despite all the opportunities, all the chances, I'd also like to give at least some small buts on this subject. But I will not overemphasize this because, as I said, we are a true believer in this success story. There are always risks in everything. If we do business without risk, everybody would do it, and nobody would really gain and benefit from that. So you have already heard that what these satellite-based broadcasting systems can offer. So they can offer a seamless coverage, which is either countrywide or European-wide. We have a unified frequency regulation for the terrestrial ground component, so in all the European countries. By means of the satellite being in place, there is a frequency regulation which has to be followed by the local nations.